Observability means identifying the internal state of the machine or system with the user data or interaction, whatever that had happened on the application. Why should we know the internal state of it? Because if we consider the modern systems, there are many applications which are on distributed platforms, and then we are having multiple touch points like data stores, messaging systems, microservice architectures, open source, exploring open source tools, and also cloud, exploring the cloud providers. So when we have these kind of complex architectures, when something goes wrong in the application, if we have to identify what is the issue, it will become very crucial to identify how each transaction had happened between these systems. To identify this, observability plays a crucial role. Let us consider a simple example like driving a car. I am driving a car. I know whether I'm able to start it or not, whether my fuel is half tank or full tank, or it's going to be empty, whether I'll be able to accelerate, apply brake. These are the details I can see or I can observe when I'm driving the car. But will I be able to know how many liters of fuel is left in the fuel tank? Or what is my RPM when I'm driving at a certain speed? And what is my engine temperature? Suppose, let us say I am driving the car, and because of some issue, my engine is heating up and I am not aware of it. If we have observability in place, probably I'll stop my car before it cause any damage to my vehicle. I would rush to a service station and then get that fixed, right? So similarly, when we are running into an issue with our software applications as well, we'll be able to identify what is the issue beforehand when we have observability in place, so that we can fix the issue before something goes wrong in our production environments, or if it creates any business impacts to our client. In this diagram, you can see we have two circles where we are doing functional testing, and also we are having monitoring systems. If we consider both for testing, we will be able to identify the failure modes, so that we will be able to identify these failure modes beforehand, and then we'll be able to fix them. And if there is something wrong which is happening with our application, at least are we at least telling the customer to wait for certain duration, or what is wrong with that with our system? So at least we will be able to provide that information to our customers, right? So before we talk about observability in software development, first of all, let us see who requires this observability. In general, observability is main concern for IT operations teams and SRE teams to make sure applications are running and it is always available. But however, observability is everyone's interest in SDLC's lifecycle. Because when we have observability, even when we are developing the systems, if we have any issue, it can be identified sooner and fixed sooner. So it will reduce our development effort also whenever we face issues while developing as well. It also helps us to identify the trends of the application uh, transactions, and how many clicks are being, how each click is being taken care behind the UI of the application and all these things. If we consider the evolution of this observability, in 2000s, we had on-prem systems mostly, and where we had to just analyze the logs to identify the issue and to come up with a solution. It was a little easier because we didn't had multiple systems to check and all that, right? So the Splunk was one of the tools which were majorly used at that point of time. When it comes to late 2000s, internet being scaled and cloud being born, application performance monitoring has become very crucial. And Dynatrace placed a market leader role at that point of time to make sure how we can monitor our systems. And we also had some of the tools like App Dynamics at that point of time. In early 2010s, we had started with cloud innings, where infra monitoring, developer first button approach, and then open source utilization, all these things had started. So this is where we have started having multiple systems in place, and then interacting with each other and all that. So at this point of time, Datadog, Grafana, all these things placed a major role in monitoring our systems. When it comes to late 2010s, where we are at a matured cloud era, where we have unification of underlying data systems and then service observations as a unit and infrastructure connection mapping. When we have all these requirements, we have to make sure we have tracing for the distributed systems, and then we have to explore automating observability so that we will be able to make sure our system is always up, and even if we run into any failure modes, or if we run into any issues, we will be able to identify that and then fix it. To come up with observability majorly, like how we are seeing in this in the picture here in presentation, to come up with this, there are four crucial things that we have to do with observability. One being open instrumentation, and second one is correlation and context. Third one is programmability, and fourth one is AI tools, AOps implementation. Open instrumentation will help us to measure the data flows in our software application with telemetry data. The telemetry data will provide us with metrics, events, logs, and traces. This is often called as MELD. And we have data, and it can be huge number of data because there will be many transactions which is happening in the application. How do we derive something out of this data? For that, we would require correlation and then context. Understanding the big picture is also vital when we have traces in place. And when we have large enterprise applications with enormous amounts of raw telemetry data and all, it is important to collect the data and analyze it and correlate the data according to the context, so that we will have some patterns and anomalies. We will have some patterns and to identify the anomalies that would arise with our applications. And programmability will place a crucial role to have the metrics in place and also dashboards, so that we will know in past, future, or present what is the state of the application. So the programmability will help us to come up with the metrics. Now we have metrics and everything in place, but will we be monitoring it all the time? No, because whenever there is a failure, if there is some flexibility where where user will be alerted, it will be great, right? So that will be done with the help of AI tools. And when we have alerts, sometimes there could be some false positives also, and we don't want to waste time of our team members or developers in trying to identify what is false positive and what is the real issue. So AI tools play a crucial role in identifying these issues. So some of the tools which does this is PagerDuty, Sentry. These are some examples which we can consider. Can we go to next slide, Badma? And what do we see with the observability? These are the main pillars, what we see in observability. First one is logs, second one is traces, and third one is metrics. Logs are the user-defined data that is provided by the developer. In most of the cases, these logs will be info logs, error logs, and debug logs. And even though we have logs, it's just a plain text that we would receive in our applications like Elasticsearch or Kibana, in tools like this. And if I run into some issue, if I have to search with the logs, it would take a lot of time and effort because there will be a huge number of logs, right? So how do I identify for what transaction this issue had happened? So that means we'll have to make sure we'll have to club all these logs in a way where I will be able to identify this according to my transaction, right? So that's what traces will help us with. So traces will make sure all these logs are combined in a place where it will create an identifier, unique identifier, where we will be able to see what are the transactions or interactions that system had done internally for the user interaction that we have made. So that can be seen with traces. We have traces in place and we know what interactions that system is doing. Is it enough? Will we still be okay? Because we cannot have somebody monitoring these traces all the time. And also we cannot wait for our customer to come and say, hey, I ran into some issue. Can you please check and fix it? And sometimes it would impact our business also, right? So to avoid getting into those kind of situations, metrics plays a crucial role. It will help us to identify the issues timely. It will actually monitor the systems timely, and whenever there is an issue, we will be alerted with uh, if we program it with DevOps will usually program it with some assumptions and then anomalies. Considering all that, we will have alerting systems so that whenever there is an issue, somebody from our team will be able to check the issue and then fix it. And coming to the benefits, Padma, can you please go to the next slide? So suppose, let us say, what do I get out of this observability? I am in an e-commerce application. Suppose let us consider Flipkart right now. I am in Flipkart and then I am doing my shopping and the page load takes 2 seconds. I'll be very happy and then I'll be proceeding with my shopping. If it takes 5 seconds, probably I would wait. But if it goes beyond that, then I would switch to Amazon and then do my shopping, right? So that's where SLOs plays crucial role. Service level objectives will make customer to be happy with the page loads and the performance of it. How do we know whether we are able to meet our SLOs or not? So instrumentation plays a crucial role in identifying whether application is able to meet the SLOs or not. If we are not able to meet that, we will be able to identify it little sooner and then make sure we reach our SLOs diligently with all our flows that we create with our applications. And when we run into some issue, since we have the internal state of each and every system, whatever we are touching upon in the backend, we will be able to troubleshoot and also identify the issue in less time. With this, we will have very less mean time to detect and also mean time to resolve. This will help us to have application available. And also we know, right, there are some targets like 4 nines, 3 nines and all that with for many of the applications. This will usually be there for mostly B2C applications. So if we want to meet that, this plays a crucial role and in identifying the issues sooner and also make sure application is always available. This will not only improve the availability and also the performance of the system because we are already monitoring SLOs as well. And coming to self-healing infrastructure, as we have already discussed, AOps will help us to identify the false alarms so that team will not spend much time on the false issues than identifying the genuine issues. So this is what it is. And coming to, why do we need distributed tracing? We already have tracing, right? But we are having multiple microservices, let us say, and then we are having multiple interactions with the data sources and then messaging systems and microservices. So one click, suppose, let us say I made a simple interaction like placing an order. To fulfill this order in the backend, first I'll have to verify whether this product is available or not. Suppose, let us say I'm trying to place an order for a phone which was launched today, and then it is selling very fast. So by the time I add it to cart, it would be available. But by the time I make the payment, is it available or not? Right. So these kind of things should be verified back, and maybe I will not know whether it is happening or not. But behind the scene, they'll have to verify it, right? So here, there are many interactions that will happen like that behind our systems. So you can see on the screen, like once I made a request, it had triggered multiple transactions in the backend systems. So you can also see the timeline below where it says how much time it had taken to serve the request and what are the internal calls that are happening here. There are some sequential calls and also parallel calls here. How do we club all these transactions? So with the user interaction, there will be a unique ID which will be generated by the system that is called trace ID. And with the trace ID, we will club all these interactions, and with the help of timestamp, we will identify whether it is a sequential request or a parallel request, so that it will be demonstrated in this way in most of the commercial observability tools, so that we need not actually go through the plain text and identify whether it is a parallel call or whether it is a sequential call. So we need not spend much time over there because it is already represented here. And each of these internal child calls, whatever this trace ID had triggered, is considered with a span ID. That's what will help us to identify what call had been had been triggered with the trace that we try to make. Coming to OpenTelemetry, OpenTelemetry is an observability framework for collecting, processing, and exporting telemetry data from various resources. It is a very vendor agnostic instrumentation library. And this can be used for multiple applications. And coming to OpenTelemetry Collector, it is a component within OpenTelemetry framework. This will collect the data, process the data, and then export it to telemetry data sources like AppDynamics, DynoTrace, or Datadog. There are multiple tools which are available in the market. So this can be integrated with any of these tools and then push the data to that. And coming to OpenTelemetry Collector, here we can see three components majorly, which is receiver, processor, and exporter, right? Receivers will help to collect the telemetry data from various sources. And this tracing data will be like logs and the traces, whatever we have already discussed. And processing this data is important because we will have to make sure this the telemetry data is transformed, and this processing will add metadata and then aggregates the metrics, and then it will provide the sampling trace data to the exporters. So when this is passed to the exporters will send the telemetry data to various backend systems like Badmavathy and then Zager, etc. So we can see the same thing in this picture. I'll hand over to Badma to talk more about trace-based testing. Thank you.
Thanks a lot, Thanusha. So
yeah. Wait a second, Badma. So any questions here so far? I hope everyone is clear. Thanks, Thanusha. So you can go ahead, Badma.
Okay. So moving on to trace-based testing, we'll see like why is it currently needed in microservices based architecture. We know that we follow the test pyramid. We try to write unit tests, then integration tests, component tests, some places contract testing, and we write functional test, which is on the top of the pyramid, right? So we are familiar with this type of test strategy, but why do we want this trace-based testing? And can this trace-based testing actually replace this entire setup? So if we just see that, I feel that trace-based testing can be added to what we currently have, but it cannot be an alternative to this. It cannot be a complete alternative to this. So let's see like what each of these phases in the test pyramid actually do. So unit test, we know that a developer writes that for like testing a unit of the product, right? It's mostly isolated, and if he needs some data, it's mostly based on mock information. So these tests are like mostly useful for the developer when he does refactoring or wants to check if the existing functionality is working fine, if he's adding to that, all of that, right? And we know that these are running in the build phase and all of that. So then moving on to integration test, let's consider this. Like there is a product microservice and it's interacting with Mongo database, which is there in some cloud SaaS solution, right? So if I want to verify the integration in my local system or during the build process, I generally spin up test containers to verify the product microservice interaction with MongoDB, right? I might actually pull up a test container for MongoDB and test against that. So this is also not similar to what we do in real environments. In real environments, we might actually have one of a microservice interacting with multiple third-party systems It might have interactions with multiple databases. It might have interactions with multiple messaging systems. And so in order to actually verify whether one particular API is working correctly, in our functional test, we might actually just make a call. We send a request, we receive a response, and we just validate the response status codes, the response body, if whatever should work functionally is working as expected. Am I getting all the required information in my response correctly? So all of that we do in our functional test. But how can we actually use this observability information, this traces, as a valuable tool? How can we leverage that to do better testing of what happens in the underlying workflows? So when one API is triggered, basically it makes call to multiple different systems, right? So how can I actually validate that? I can validate that with this trace information. So that is why we are saying that observability can help us actually do more than what we are currently doing. And let's see like how this is done. Like, is this already being supported by any tools and all of that? So currently there are some tools, but all of them are in nascent stages of development. And we are selecting trace test for our demo here because trace test actually supports a lot of integrations with most popular observability tools that we have in the market. They have support to almost all, I can say. So, and all of these systems are also working based on the common open telemetry framework, right? So it is easy for us to actually incorporate any new observability tool also if it is actually based out of open telemetry framework. So if we want to see the architecture, basically this tool will trigger the API transactions first, and this triggering can actually make the application code run, and it will generate the telemetry information and will write to the data store. So our tool, once it writes to the data store, we'll be fetching that traces. We'll do the orchestration. We'll get the trace. And then we will assert on the traces, like what information I need to assert. So assertion can happen with three different like concepts. Like, so there will be selectors. So I get a list of trace information and I can select what are the different spans that I want to actually validate against. So I can use some selectors to actually select which span I want to consider, and in that particular span, what are the different attributes I want to assert against. So I can write assertions based on the traces, and then I can actually execute the run, and I can see whether it passed or it failed. So this is the rough architecture. Moving on, so how can we actually execute our test? How is it done? So trace test actually provides a UI where you can actually select all these things, view the traces, write all of these things in UI format. You can select different things and come up with this kind of test definition. So when you export the final thing that you do in the UI, you get something like this as a YAML file. Here you can see there are different components. There is a type, there is a spec. So spec says that I want to do this particular trigger. It's a HTTP request. I want to make a call to this particular endpoint. I specify methods, headers, and all of that. I also specify the body. So once I make this trigger, I need to fetch all the traces, and trace test will do that. We need to configure for that. And there is going to be some test specifications that we want to do. So here I want to validate whether all of my HTTP spans in that entire transaction is like 200. So I'm specifying my selector. So I want to select a span which is going to be of type HTTP, and method is going to be of post. And I need to give my content type as application JSON. And what do I need to assert? So selectors can return one or more spans, right? So if it is one or more spans, it has to assert against all of that. So I'm asserting that all of my HTTP calls should be returning status 201. And my request header host should be of this value. So this is an example of one test specification. So this is how you do that in UI. The right side diagram that you see here is the trace test tracing. whatever tree that you see here, it is what is happening from the application side. And these are the telemetry information it has actually fetched from the OTTL supported data store. So our application is actually writing logs to OTL collector, and OTL collector is actually exporting them to trace test. And with that information, trace test is able to come up with this kind of tree structure. So here, like I said, you can write the specifications. This is the UI that you can see. Here I can select my spans. There is auto complete functionality here. When you start typing, it shows you with all possible values, and you can add assertions, and you can also give it a name and then save the test specifications. So let's see a demo of how we can do this. So starting with the configurations. So first I have to specify my OTL collector configuration. So I'll specify what will be my exporter, what will be my processor, what will be my receiver. And I'll also specify my hotel pipeline. So pipeline is going to contain all of these three things that we've defined here. So exporter, I'm going to export to this particular endpoint where trace test will read that telemetry data and use it for its testing. So this is the exporter, and I'm going to give some configurations for my processor, like what should be the timeout. And the receivers, I'm going to use this open telemetry protocol for reading the HTTP and gRPC calls. So I'm going to receive all of these things with this particular protocol from my receivers. So our application will have some agents which will actually send this information to hotel collector. So coming on to trace test. So trace test will internally use Postgres database for saving all your test specifications, your test runs, your test results. All of that information will be used, will be stored in the Postgres database. So this is just configuration for connecting to that. And the next one is you can see that trace test, we also need to provision for it. So what is my data store? What is the type of config that I need? What will be the polling profile? How long it should wait for the traces to appear in your test, and what type of application you're connecting to. So that thing, we are actually giving that also as a configuration. Now for my demo, I am actually using Docker for spinning up my services and the dependent services also. So as you can see, I have Redis as a cache running. So my application will be writing or reading to this cache. And this is exposed at 6379. And similarly, I'm having a microservice running, which is Pokeshop. And it is using all this information. It is using Redis, it is using Postgres, it's also using RabbitMQ as a queue. And I'm specifying some of the other configurations that I need. Similarly, I'm having one more app running for gRPC calls, and there is also a demo worker. And this is my hotel collector. So hotel collector, whatever configurations I have given, all of that information should be mapped here as well. I'm having my Postgres, and there is RabbitMQ, and then trace test. So here I'm pulling the trace test image, and I'm actually specifying these are the configurations that I need. So I need to do the trace test provision, and I also need to specify the trace test YAML. So this is the entire Docker Compose file that I have. And I have started the service, and my trace test is running in 11633. So I have actually opened the trace test here. So this is how the dashboard looks. So all of the configurations that we saw can be seen here also. So analytics, we said, I want to enable analytics. Trace polling should be for 2 minutes, and retry delay has to be for 3 seconds. And this is the endpoint that I'm going to use for my demo. And I'm not using all of these. I'm just using the open telemetry collector. So whatever information that I've given there in that YAML file, the same is present here also. So you can see what type of configurations you have done in the settings tab. And here you have test, and here you have environments. So environments, you can create some environments to have some variables that you want to use across tests. And there are these tests. So here you can create a new test or new test transaction. So the difference between test and test transaction is that transaction is like a group of tests. It can be compared to your test suite. kind of test suite. So where you can like group test and run them in a single click. So this is on that. And as you can see, there are multiple versions of this also. So whenever you edit this particular test, a new version gets created, and you can run a particular version the way that you want. And you can also have an option to view all the runs. Similarly, you can see lot of the versions here. So for all of these things, you can see there is pagination also here. And let's see a transaction. So here in the transaction, I have actually given 3 tests, and each of the 3 steps are actually showing up here. Here it is showing it has passed all the assertions. And if it is any failure, then it will show here. So if I'm triggering run transaction, it will start running that. So this is on the transaction. So if I want to actually create a new test, I can give this, and then I have to select the HTTP request or gRPC, whatever it is. You can also use your Postman collection. It will just do a complete import of all the APIs that you have. So when you give HTTP request, and you can just give something like, I want to actually use this API, and then I want this authorization type. This is my header list. I'm going to give a JSON response, JSON request body. So I can just create. So it is actually triggering it, and it gave me a response also. This is the status code, and this is the time that we got. So now it says I have executed this, and I've added this to the database. And there is this trace that I received for this particular transaction. So here, trace is doing the trigger to the endpoint, and the endpoint is being invoked. We are validating the request. There is a create call in the database. It's doing an insert query. So all of these things, we can see what is happening behind. And here you can define the test specification. So in this, I want to select HTTP. So for that, you can select your spans. So automatically it is filling it like this. So here you can select any of these traces, and whatever assertions you want, you can do that. So here I am adding, so I have selected this particular span. Now I want to validate whether this is the only span in the entire trace. So which is actually satisfying this type of HTTP. So I don't see any other HTTP calls happening in this particular flow. So it should be selected spans should be 1. Yeah, so HTTP, whatever I have done, it's only 1. So it says selected span count should be 1. And you can give whatever name you want, and you can actually save that. So here it says it has failed, because when I'm doing an ad, it's actually giving me 201 as the status code. So this is how you see the failure. You can go ahead and edit it. So now I can see there are 2 successes. So I can save this particular thing, and if it is a new version, it gets added as version 2. And similarly, you can set some output variables also. Here, while you're actually making some assertions, you can also, whatever response that you see in this particular HTTP call, right? That response can be actually saved as a test output. So here you can select that attribute, and you can give it a name, and that will be coming under environment. So you can access those variables also. So in that way, you can change some request and see how you want to do. And then, so this is how we generally do. So let's see what is the trigger that we did for the transaction. So all of them succeeded. Here you can actually go inside and see again what is the test and how it ran, what are the different assertions it did. So here also I'm doing similar thing. I'm also verifying the method. So there are 3 assertions defined. So for one particular API call, you can trigger multiple test specifications also. So that way we can do many things. So any questions on the tool, or any questions on the way that I showed the demo? Okay, you can feel free to actually add the questions in the questionnaire. So moving on from the demo, So what do we actually get from this trace-based testing? So in generally, you can see that in most projects, observability, like setting up the logging system, setting up the monitoring system, all of that come as like a production checklist, right? Production ready checklist, something like that. So this actually makes that observability should be essential part of development and testing. So that way we are shifting something that happens later part of our development life cycle to something before, and we are actually using that for testing also. So that can be a good practice, and it needs some process changing also. People should change, and that sort of setup should be like acceptable to everybody in the team. So that is something that is a positive that we can do. And we have to make, if we are actually moving this in the front and we are doing testing, it also improves the feedback loop, right? You can find more issues prior in the cycle, and that actually helps a good feedback loop. And we are not just asserting on the status and the response that we get. We are also testing the underlying flow, which is actually very, very valuable, right? So that is one thing. And it can also be combined with functional performance testing. All that you have to do is like you have to see if we can, instead of triggering it from trace test, are there any integrations with some other tools that trace test support? So currently trace test is supporting K6. So K6, if you have K6 strips, you can actually integrate that with trace test, and that can actually lessen your efforts to create the test trigger setup. So and we can also be sure that when there are like multiple third-party systems involved, we can be assured that we are testing more closer to the reality of production instead of like testing with mocks or other mimics, right? So those are the benefits that we get. And coming to the challenges, we see that like generally it's last in the development life cycle, there's observability implementation, all of that. We have to make sure that we have to do it prior. This involves like a lot of efforts from DevOps teams and every other teams, right? So this is kind of a challenge because most projects, they have to do that mind shift change, right? So that is one of the challenge. And this approach for testing works only when there is tracing implemented across all integration points correctly, right? So if there are some integration points where we cannot achieve, our traces don't reach till that point, or we are doing mocks in that place. So in those situations, we are unable to actually verify that. So that can be one of the challenge. And so also complexity can increase when you're testing in an environment which includes like caching, circuit breakers. So in caching, you don't actually make the entire call, right? The CDN actually returns you with a response. It's cached already. So in that situation, you cannot actually check for the trace. You will not get it. And it would be difficult, right, to validate our traces. And in case of circuit breakers also, like if underlying service is not responding for some time, it might actually give a response that is not the right one, right? So these can also happen with the trace validations. And the trace data setup and triggering these transactions, that can also add up to the complexity based on the system that you're testing and how many integration points that you have. So all of that can also increase that. So this is all that we have. Like, any queries?
Yeah, people, do we have any questions? I think there is one open question in the Q&A.
Okay, trace test allows external scripting of test assertion under test tab, like we do in Postman. No, you have to actually define your test assertion because they are based on the traces, right? It cannot be done externally. So you can actually do that in your YAML configurations. You can write YAML, the test definition that you saw, right? There you can add more of these things. But externally, like some integration, that is currently not possible.
Yeah, Hope the question is answered. Thank you, Padma and Thanusha, for the session. So trace-based testing is something which is coming up now. And I think you have given a brief detail of the same and a very nice demo as well. So this will be a big takeaway for us. And yeah, so now we come to the end of the event. So thank you all for attending it. And thank you to the people in joined virtually the webinar. And thank you people for joining us in person. So it was a very great event to see you all after a really long time. We are conducting this in hybrid mode after the COVID. So this is the first time we are conducting in a hybrid mode. So yeah, see you all soon.